Alright, so I think I'm recording. We're doing these problems for our review of Scale 4, which is polynomial and rational functions. So here I have a rational function, a ratio of two polynomial functions. They want me to determine the location of any holes and also the equations for any vertical asymptotes if they exist. So I need to factor both my numerator and denominator. So in the numerator I see that 8 is the greatest common factor. In the denominator I can see that x is the greatest common factor. And I suspect that we can factor this trinomial. If we can't, we can use the quadratic formula to find the zeros. The leading coefficient's a prime number, so at least that makes it, easier. And my 25, well, 1 times 25 or 5 times 5, so I suspect it'll be 5 times 5. Since the last term is negative and so is the middle term, I need these to be positive and negative. The 2 times negative 5 is negative 10, then plus positive 5, that's how I get the negative 5 there. So I can see that I now have it completely factored. I have a factor in my numerator that cancels with a factor in my denominator. My reduced rational function, provided that x is not equal to 5, is this. So I have two vertical asymptotes. The vertical asymptotes, you set the remaining factors after you've written it in lowest terms equal to 0 and solve. So this gives me the line x equals 0 for this factor of x, and the line x equals, well, it's a two-step equation. Subtract 5 and divide by 2. Because if you come over and set that equal to 0, it just takes 2 steps to solve that. You subtract 5 from each side, and you divide by the coefficient to get x by itself. That's how I got the negative 2/5. Now, we had any factors that cancel appear on the graph as a hole. So we have a hole in the graph. For a hole, we want to give the location of that hole. We're working in a coordinate plane, so we define points to be x comma y, the location anyway. The x minus 5 is the factor that canceled. If you set x minus 5 equal to 0, then, well, 5 minus 5 is 0. Now, students sometimes have difficulty finding the y-coordinate. If you plug that 5 back into the original expression, you're going to get 0 divided by 0, which is undefined. You have to plug 5 in to the fraction after you've written it in lowest terms. So my numerator is 8, my denominator is a factor of 5, and here 2 times 5 is 10, and 10 plus 5 is 15. 5 times 15 is 75, and 75 and 8 do not share any common factors. So there's the location of my hole. I had one hole, and it's located at 5 comma 8 over 75. Alright, so let's move on to, I believe the next problem has the same directions, so we'll do it on the same video. Yes. So let's start out by factoring both my numerator and denominator. I see that there's a greatest common factor of x when I look at the terms of the numerator. In the denominator, I have a trinomial. The leading coefficient's not 1, but at least it's prime. And the factors of 8, well, 1 times 8 and 2 times 4. Now, since it's negative, one of these values have to be positive and one has to be negative. Let's see, if I have 3x times a negative 1 is negative 3x, and 8 minus 3x is 5x, so there I have it. Now, in the numerator, I can still continue to factor because x squared minus 1 can be thought of as x squared minus 1 squared, a difference of squares, which factors to x plus 1 and x minus 1. We have a common factor in the numerator and denominator that cancels. And I'm left in the numerator with x times x plus 1. And in the denominator, 3x plus 8. That's provided that x is never equal to 1. If x were equal to 1, it would not reduce because you'd have 0 divided by 0. Alright, so now the vertical asymptotes is what remains. So I have one vertical asymptote. It's the line. You always want to give an equation for a vertical asymptote and never just a number. If 3x plus 8 equals 0, you can solve that in 2 steps. Subtract 8 and divide by 3. The factor that canceled, if you set that equal to 0, well, that's just one step. Add 1 to both sides. So there's one hole in the graph. We need to give both the x and the y coordinate. The x coordinate, since 1 minus 1 is 0, x equals 1 is the x coordinate. And now I plug 1 into the reduced fraction. If I plugged it into the original, I would get 0 divided by 0, which is undefined. So if I plug it into the reduced, I have 1 times, well, 1 plus 1 is 2. And 3 times 1 is 3, and 3 plus 8 is 11. So we have 2 divided by 11. So I hope that helps in finding the equation for the vertical asymptote and the location of the hole for this rational function. So I'll do the other problems on the next video. Talk to you later.